Hello everybody. I want to take a chance to do this problem, which at least at the time I'm making this video is from assignment 2.3. So it's kind of a simplified version of a lottery game. You bet $3 or you pay $3 for a ticket. Um, and you select three digits, each between 0 and 9 inclusive. Okay? Um, and if the same three numbers are drawn in the same order, then you win and collect $600. Okay, complete parts A through E. So for part A, how many different selections are possible? Uh, Here's something I want to say about that. One thing that I don't think the question makes very clear, but that is implied in there, is that the digits can be repeated. Uh, and I say that that's kind of an important thing about this because if I think about selecting numbers in a lottery, they can't be repeated. All right. So like maybe the first digit 0, and then the next one is 1, and then the next one is 8, or something like that. Like you're not gonna, once the first one turns out to be 0, you won't get another 0. That's how I ordinarily think of a lottery. But like in this one, like the digits can be repeated. So like the number 000 could show up, or 001, or 002, like where the zeros are repeated, or maybe the ones are repeated, like 101, and so on. Now, okay, I just want to establish that the digits can be repeated. Now, here's the way I would think of how many selections are possible, right? And I'm trying to write out like, well, the possibilities, they look like this, like 000, 001, 002. And if you ask me how many different numbers are possible, then I think of it like, well, all right, like, can you agree with me the possibilities look like that? And I think of it like if I count from 000 up to 999, right? Because like 9 is the biggest number that could be chosen, and like if all digits are 9, that is the biggest number, of the three digit number. Okay, so I think about all the possibilities like this, and it's like from counting 000 up to 999. How many numbers are going to be there? If you count from 0 to 999, think about kind of like that. Well, if I count from 1 to 999, that's 999 numbers. And if 000 is the first one, then that would be 1,000 possibilities. Okay. Now that's how I would do it. You could also use the multiplication rule, but I think it's simple enough. Once, especially if I write out the possibilities and say you think of it like this, then maybe that's easier to understand. Okay, so let's see. 1,000 different selections. And we put that in, and that's it. There's 1,000 possibilities. Okay, next one. What's the probability of winning? Well, I'm going to choose one of these numbers to be the winner. And it may or may not come up, but that's only one way to win out of 1,000 total possibilities. Okay, so that would be 1 out of 1,000, right? That's how we would calculate that probability. Only one way to win out of 1,000 total outcomes, 1,000 total possibilities in this game. So you get that. Okay, 1 out of 1,000. If you win, what's your net profit? So I noticed they said net profit. You might think if you win, somebody hands you $600, and it might be tempting to say that that is your net profit. But you got to think, we started the game by handing over $3, and then if we win, we are handed back 600. So I got to factor in the fact that I'm actually, like, I gave $3 away. I lost $3 to even play. So my net win wouldn't be 600, it'd be $3 less than that. So 597. All right. Okay. There we go. Now it says, what's the expected value of a for $3 bet? Okay. So the expected value of a random variable or a gambling game is like, it's going to tell us like a prediction of the long-term average win per play. Like, so if I were to play this over and over and over, the expected value would be a prediction of what my average win is going to be per play over the long run. Like if I play lots of times, okay? And I say win per play, I think with any kind of gambling game, it's most likely that there's going to be a long-term average loss per play, okay? So, well, here's how I would do that. So I gotta move this around real quick. So this is part D. Okay. All right. So for part D, my expected value is, oh, whoops. I'm going to have to pause and then write this down and then describe it to you. Okay. So I got this, my computer situated. I was going to do the expected value for a $3 bet. So our formula for the expected value is the sum of each outcome times the probability of that outcome. And I may have written this formula down a little bit different in some other videos. You might say the value of the random variable times the probability, but it turns out to be all the same thing. In this problem, one outcome is that I win $597, and that has a probability of 1 out of 1,000. Plus, the other outcome is that I lose $3, so I put in a -3, and that has a probability of 999 out of 1,000. There's one way to win and 999 ways to lose, okay? And if I calculate this, I'll get -2.4. I interpret that as -$2.40, meaning over the long term, I will lose $2.40 per play. It might be that sometimes you win $597 and sometimes you lose $3. But if you average that out over lots of plays, if you actually did this with the odds that are given and the wins and losses that are given, over the long term, you'd be like you lost $2.40 per play. Okay, so in the long, you might win the first time you play, but if you keep playing, you average out to a loss, is what we're saying. So let's see. I'm going to do -2.40, okay, dollars. All right, and I'll check that, and it's correct. One last thing is this. We'll compare with a casino game. Suppose you tell me that you bet $3 on a certain casino game, and the expected value is -2.6. Now look very closely. That's cents. Okay, which bet is better in the sense of producing a higher expected value? Now in this case, I notice that it's asking me to compare this lottery game to some casino game. Okay, and they both have a negative expected value, meaning you might win or lose on any play, but over the long term, you're going to lose per play. You'll have a long-term average loss. But I noticed that although they're both negative, this is less negative. Here, I'm going to lose $2.40 per play over the long run. And here, this says I'm going to lose 2.6 cents. Well, what would you rather lose? Would you rather lose $2.40 or 2.6 cents? I think it'd be better to lose 2.6 cents. That's less of a loss. So that's what it's asking. So I would say, well, to compare these two games, the casino game is better because it has a larger expected value. I know it's a little strange to think of that number as larger than this one, but it's larger in the sense of being less of a loss. All right. Okay, so that's how we can answer all parts of this one. Hope that helps you with it. Let me know if you have any questions.